Okay, today we're going to look at section 4.1 called inverse functions. So the definition of the inverse of a relation is it is a relation that reverses another relation. Now, when you think about inverses, you're thinking about the inverse of possibly addition, subtraction, multiplication, division, square, square root, cube, and cube root. So when we're looking at inverses, we're looking at the opposites. So the opposite of multiply is divide. Probably be helpful if you make this chart with me. The opposite of add is subtract. The opposite of squaring a function is taking the square root. The opposite of cubing a function is taking the cube root. Okay, remember that a square root doesn't have the 2 there, but it is a square root. Okay, so when you're looking at that, make the chart, and that will help you when we start undoing these operations in a few minutes. Okay, there is a symbol for the inverse, and the symbol for the inverse, if you're looking at an example such as R, is going to be R to the negative 1. So that signals the inverse of the relation R. So remember that the relation is a set of ordered pairs. So if you are trying to get the inverse of that, where it says R raised to the negative 1, you're going to interchange your X and your Y. So with the inverse, this Y is now going to become the X. That X is now going to become the Y. So you're flip-flopping those ordered pairs. So then I'm going to interchange negative 1, 2 to 2, negative 1. And then I'm interchanging negative 4, negative 2 to negative 2, negative 4. And then 6, 3 will be interchanged to 3, 6. And then I'll close the relation, the set. So again, when you have your X and your Y, the inverse is going to be Y and then X. Okay, so if something is 1-to-1, the definition is it's going to have a relationship if its inverse is a function. So as you look at the definition, it is going to have a 1-to-1 relationship if the relation and its inverse are functions. So they both have to be functions. So that makes us think back to when you're looking at the question R and R inverse. How can you tell if those are functions? Remember that you're going to look at your X when you have ordered pairs. So when I'm looking at those X values, they're all different. So that means that the R is a function. When I look at the inverse of that function, I'm looking at the X's now. And those are also different. Remember, to be a function, your X's cannot repeat when you're looking at your ordered pairs. So when you're looking to see if something is 1-to-1, you have to look at your original function at your X's, and you have to look at your inverse at your X's. So if it is a function and the inverse is a function, then you would call that a 1-to-1 function. So the function itself the relation itself has to be a function, and the inverse. And then it would be 1 to 1. Okay. Now, when you're looking at a graph, you have to first of all remember that it must pass the vertical line test in order to be a function. Okay. So when you're thinking about the vertical line test, if you remember, when you graph a graph, a vertical line can touch the graph in only one point. So in order to be a function with a graph, you have to do the vertical line test. Okay. Now, to be able to determine if it is a 1 to 1, it must also pass what is called the horizontal line test. That helps determine if the inverse is a function. So remember that both the relation and its inverse must be a function in order to be 1 to 1. So when you're looking at your graphs, the first thing you want to do is you want to do the vertical line test. If you say no to that, then it is not going to be 1 to 1. Okay. If you do, because it's not even a function. So it has to be a function before it can be called a 1 to 1 function. So when you're doing the vertical line test, you can see right here, if I did the vertical line test, it would touch more than one point at the same time. So this one is not a function. So therefore, it cannot be 1 to 1. Now, if you put yes, if it does pass the vertical line test, and you put yes, then it is a function. So you want to think about the vertical line test first. So when I'm going through these, all of these would pass the vertical line test, except number 6. Okay, so if you say that it is a function, to check to see if it is a 1 to 1 function, you have to pass a horizontal line test. The horizontal line test is just like the vertical, okay? It only can touch one point when you do the horizontal. So if I did the horizontal on this, it would only touch one point. So this one would be a 1 to 1 function. If I did the horizontal line test on this wave curve, you can see that it is touching more than one point at the same time. It is a function, but it is not 1 to 1. If I do the horizontal line test on the rational function, you can see that it is only going to touch one point at the same time. That's just getting closer and closer, so they're not going to reach the same point with the asymptote. So this one would be a 1 to 1 function. Okay, doing the horizontal line test here would only touch one point as well. So this one is a 1 to 1 function. Doing the horizontal line on a horizontal line, it's going to touch every single point. So it's definitely not 1 to 1. And if it is not a function, it's definitely not going to be 1 to 1. Okay, so sometimes when you're doing your examples, it might ask you, is the relation 1 to 1? So if you were to answer that, you would put a yes for number 1. This one would be 1 to 1. You would put a yes for number 3, and you would put a yes for number 4. Everything else would be no if you're looking for 1 to 1. So it can be a function, but not 1-to-1. So this would be a no for that one if you were answering that question. This one would also be a no. And this, of course, was a no. Okay, so the only ones that were 1-to-1 is number 1, number 3, and number 4. Okay. Okay, so now we're going to verify graphically. So remember we were talking about switching the x's and the y's. So if you label your function f of x, that would be this one. Okay, we're going to look at some points on that line. So you might have -7, -3, -1, 0, 1, 1, 3, 2, and 5, 3. 5, 3. Okay, so now to get the opposite, which would be the inverse, that would be your g of x, which would be this line. If you are to flip-flop those, then those two lines are going to be inverses. So that means that -3 should give you -7. 0 should give you -1. 1 should give you 1. 2 should give you 3. And 3 should give you 5. Okay, so when you're looking at that, also the other thing about inverses is they must reflect over the line y equals x. And remember, that was our identity line. So y equals x, if you remember, is where you get back what you put in. So you get back the same number. So this right here is the identity line. That's your y equals x. So both of those, if you folded across that, would touch those points. So if you folded your pink or you folded your yellow over, okay, that line. So they are going to reflect over the line. You're also going to notice that in your table, if you were to look at your domain of f of x, which is -7, if you're just looking at your table, -1, 1, 3, and 5. If you were to look at that, that is going to be the range in G. So those numbers should flip-flop. So your domain in F, right here, should be the range in G. Okay, the same thing if you're looking at the range of F. Those points should be the domain in G. So these points right here, which are your X's and your Y's, are interchanged. Okay, so if you will pause the video and try to work the other question, which is letter B, and then unpause the video and we'll see if you did okay with that one. Okay, as you look at letter B, let's see how you've done. Hopefully you looked at your f of x function and you graphed those. You can see I graphed mine in green. Then it says to do the inverse of your g. So you're kind of trying to switch those points. So you're switching the x and y's. And then you are graphing the ordered pairs for g. Mine is in purple. And then you're looking to see if the two lines reflect over your identity y equals x, which is yes. Okay, so let's look at letter C. Sometimes it will give you a function. So it tells me that my function is y equals 3x plus 6. So let's go ahead and graph that. That's going to be lettered F. So I'm going to go to plus 6 and then go ahead and graph that line. Okay, so you should have a line that started at your y-intercept of 6, and it should be rising with a slope of 3. Okay, now what we're going to do that's new is we're going to try to find a function g. What you do to find the equation is you're going to switch the x and y values. So what that means is my y is going to become my x, and my x is going to become my y. Okay, now we need to solve for y. So I'm going to subtract my 6 and divide by 3. So we're going to get 1/3 x minus 2. Okay, that is going to be my g. Okay, so if you'll go ahead and graph g and pause the video. Okay, check your line. Make sure that it reflects over y equals x, which it does. And now we're going to identify the points. So if you look for your x in the purple, if it's -1, what is your y value? So we're looking at this one. So if I go to -1, my y value is going to be 3. Okay, so this answer would be 3. So if I look at g of 3, which means the x is 3 this time, so I go to the green, and it goes to -1. So the g of 3 is -1. So notice that those points right here are flip-flopped. Okay, so we have f of -1 being 3, which means that's -1, 3, and g of 3 being -1, which means 3, -1. Okay, so if you think you understand, if you'll pause the video and you can try letter D. So the first thing in question 11 is we're asking ourselves, does the parabola pass the vertical line test? And that would be yes. So now we're going to reflect that, and we're going to try to sketch the graph of f of x that reflects over the line. So we would have a point still at 0, 0. If we have a point at -3, 2, if we have a point at -3, 2, then there would be a point at 2, -3. 2, -3 should be over here. 2, -3. So if I have a point at 3, 2, then there should be a point at 2, 3. So let's draw that. Okay, so we see that we're trying to reflect that, but you can see that now it does not pass the vertical line test. Okay, so that would be no. So this one would not be a one-to-one function. So the parabola is not one-to-one. And you can see that it is not going to be flipped correctly. So when you're looking at that and you're flipping it, it is not going to pass your one-to-one. That's why earlier when I said it must pass the horizontal line test to be one-to-one, this one failed it, because if you flip them, then it would not pass the vertical. Okay, so looking at g of x, this one would be yes. So see if you can do your reflection. So what I did was I found kind of 2 points. So I had 0, 3, it flipped to 3, 0. And then I had -7, 2. Yes, -7, 2. And so it flipped to 2, -7. Okay, and this would reflect over the line y equals x. So when I reflect that, it would pass your vertical line test. And so this would be one-to-one, okay? So in the trisection, if you would go ahead and make your T-charts and go ahead and do the reflection. Now, if you can do the reflection without making the T-chart, like I was trying to show you a moment ago, that's perfectly fine. But make sure that you are sketching the inverse. Also, make sure you are drawing the identity function as a dotted line that you are reflecting that over, okay? And then you can come back and check your work. Okay, as you check your answers, you might want to pause the video. But again, the first thing you want to do is you want to write down the ordered pairs for your function. You want to flip your x and your y, and then you want to graph and reflect them over the line y equals x. So that would be number 1. Number 2. And then lastly, number 3. Okay, so we're going to look back over where I was showing you a moment ago how to find inverse functions algebraically. So the first thing you want to ask yourself is, does it pass the vertical and horizontal line test? So it has to be one-to-one in order to have an inverse. So when you're looking at these algebraically, you need to think of the graph of the function first. Okay, so next you are then going to interchange your x and your y. Make sure that you put y for f of x, because that's what f of x means. You're going to flip-flop your roles. You're going to solve for y, and you're going to replace your y in your new equation with f inverse. Okay, so that would mean the inverse of y. So first of all, we're thinking about a line. So after we've looked at our graphs, I hope you know that that would pass the horizontal and the vertical line test. So I'm going to go ahead and put y for f of x. Okay, so that would be your step 1. Think about your graph. Step 2, you're going to put y for f of x. Step 3, you're going to interchange your x and your y. So you're going to interchange your x and your y. Okay. Step 4, you're going to use algebra to solve for y. So we would have x plus 8 equals 4y. divide by 4, and we get y equals 1/4 x plus 2. Okay, then we're going to interchange the y with f of -1, because that's the inverse of my function, and it would be 1/4 x plus 2. Now, if you want to check these, you can always type these into your graphing calculator. You would type your inverse and you would type your original function and see if the graphs are flipped over the line y equals x. So I graphed both functions. So I graphed the original given, I graphed the inverse, and then I also graphed the identity. So you can see that they are reflecting over y equals x. When you go to your t-chart, you can see, for example, 3, 4 would be 4, 3 in the other function. So the x's and y's would be interchanged, okay? So a cubic graph, if you think about a cubic, it would pass both the vertical and horizontal line test. So we're going to go ahead and replace f of x with y. Then I'm going to interchange my x and my y. And now I'm going to solve for y. So we're going to subtract 1. So I'll have 1/2 y to the third equals x minus 1. I'm going to times by 2. So the 2's will cancel. So I'll have 2x minus 2. Okay, to get rid of a cube, I'm going to take the cube root. So the inverse of the function would be the cube root of 2x minus 2. So when you graph both of those, if you want to check again, the cube root, if you don't know where that's at, is if you hit the math button and you go down to number 4. Okay, so when you look at your first function and your second function, and then I have the identity last, you can see where it's reflected over the identity line. And you can also see, for example, if that's 2, 5, down here we have a 5, 2. Okay, see if you can do the last two. So just kind of pause the video. So I hope when you looked at this one, you remembered that this quadratic meant it goes right 4 and up 6. So when you think about that quadratic and it being foldable, you notice that if you were to reverse it, you would have 7, 3, and 7, 5, which means when you look at your table for that function, if you did the inverse, you're only going to have one output. So when I go up here, you see where it's 3, 7, and 5, 7. But when I go to 7 for the inverse, I would only get the 5. Okay, so what you have to remember is if it does not pass the horizontal line test, okay, then it's not 1-to-1. So if it's not 1-to-1, it has no inverse. So make sure you check that first if you did not when you did that question. So always do step 1 and think about the graph. And when you're dealing with the quadratics, which are the u's, they're not going to pass horizontal. Okay. So in number 4, this one would be, you know, the hyperbolas with your asymptotes. So this one would pass. the vertical and the horizontal line test. So go ahead and see if you can flip-flop your X's and your Y's. So first of all, I'm going to replace that with Y. Then I'm going to interchange those. And remember that you're solving for Y. So when you got to this part a while ago, if you tried it, you might want to put a 1 under that and cross multiply. Then you're going to distribute. So then I'm going to add over the 8x. And lastly, I'm going to divide by x. Remember to change your y, since this is the inverse, to f negative 1. And then the inverse would be 8x plus 5 all over x. So if it asks you for your domain and range, remember that your vertical asymptote is you cannot divide by 0. So x cannot be 0. That's going to affect your domain. So your domain is going to be every number but 0. So it'll be negative infinity to 0, union 0 to infinity. Okay, the range, you're going to look at your horizontal asymptote. Remember, with your horizontal, you're looking at the degrees, and both of these are the same. So you're going to divide 8 by 1. So your horizontal. So after you divide and you get y equals 8, that's going to be affecting your range. So it would be from negative infinity to 8, union 8 to infinity. So when you deal with your rational functions, remember that you have those asymptotes that you have to go back and think about, okay? Okay, to verify inverses algebraically, you have to do the compositions. So f of g of x and g of f of x should give you x. So we're going to do the next 2 questions algebraically to see if we get back the identity function. So as we go to this one, we're going to try f of g of x. Okay. And so that means that I'm going to write down my g of x. And everywhere I see the x in g of x, I'm going to put 2x plus 7. So after I have put the 2x plus 7 in place of the x, you're going to see that the 7 and negative 7 undo each other. Then you're going to get the 2x over 2. So you can see here where the multiplication of 2 and the division of 2 are going to cancel each other out to 1. So they undo each other also. And you get x. So this one works. So f of g of x gives us x. So now we're going to try g of f of x. So I'm going to have g, and I'm going to put the f of x function down. Now I'm going to take this and put in place of x. I'm going to have 2 times x minus 7 divided by 2. So the division of 2 and the multiplication of 2 cancel each other out. I need to go ahead and put the plus 7. The plus 7 there. So they're going to cancel each other out. So then I have the x minus 7 plus 7. and the -7 and +7 cancel each other out. So you get back your x. Okay, so that one checks as well. So when you're doing the compositions, you are showing that when you plug one function into the other, you're going to get x. And when you plug the opposite function into the other one, you're also going to get x. Okay, go ahead and pause the video and try number 2. So when you did the f of g of x, we're putting the g of x down and we're plugging it in place of your x. So now we're going to take this and I'm going to put it in and square it. Okay, so when you do that, the square and the square root are going to cancel out. And the +5 and the -5 are going to cancel out. And you do get your x. Okay, so now we're going to do g, and I'm going to put in the f of x. And now I'm going to put that under the square root. So I have x to the second -5 plus 5. The -5 and +5 cancel. So the square root of x to the second would be x. Okay, as we use the graph to find the inverse of -3, let's first of all kind of look at the function. So go ahead and try to write down your ordered pair to where you think in the original function, your y would be -3. So right there, you would notice that the original function, it's 0, -3. So in the inverse function, it's going to be -3, 0. So this answer would come out to be 0 for this one. Okay, use that and try to make you a T-chart to think about number 2. And we're looking at the domain and the range of both the original function and the inverse. So when you have an equation, you want to make a table and try to think about your graph. So a square root would be curving in one direction. And you can notice that the domain here is going to start at -6 because you cannot take the square root of a negative. So as you are thinking about your domain and range for that function, go ahead and plug those in. Make sure you start at your -6 and then pick numbers that would be bigger. So if I'm looking at bigger than that, that would go to -5. And then you could go maybe to the number 3. Okay. So thinking about that, try to get you some y values. Come over here, try to interchange that and come up with your inverse function, and then we will look at that T-chart, okay? So when you took -6, the square root of 0 is 0. 6 plus -5 is 1. The square root of 1 is 1. 3 plus 6 is 9. The square root of 9 would be 3. Okay, so now I'm going to interchange my x and my y. And now to get rid of a square root, I'm going to square both sides. So I get x to the second equals 6 plus y. And then I will come up with y equals x to the second minus 6. So the inverse is x to the second minus 6. So when you look at this function with the square root, you can see that it's going in the direction toward the right. So it's telling us that our domain needs to be from -6 to +infinity. okay? And when you're thinking about that, remember that you have this greater than or equal to 0. So then when you solve that, you get greater than or equal to -6, okay? So then the range is going to be, when you think about this number, -6, 0, the range is going to be 0. And then what happens after 0 is it goes to positive infinity, okay? So as you're looking at these graphs, you possibly want to graph those. And when you go to your T-chart, you can look at the numbers that possibly would give you whole numbers to help you as you graph. And then you could see there's a -2, 2 there as well. And then that would be the 3, 3 that we picked, okay? So when you flip one of these and it tells you some of the restrictions right here, it's going to be easier to get that table and then go over here for your inverse and flip those. So for my inverse table, I'm going to interchange those points. So I have 0, -6. I'm going to have 1, -5, and 3, 3. Okay. And so you can see what's happening here is my domain is now going to be the range of the other one. And my range is now going to be the domain of the other one. So when you're looking at the graph of this one, you're not looking at that whole parabola. You're only looking at the part where it started at 0, which is right here with your 0, -6. Okay, and then you can see with that, your domain is bigger than 0, and it's also bigger than -6. You're only looking at that 1/2, okay, of that parabola because you need to flip those, okay? And then you can see where it would be an inverse over the y equals x line. So the final thoughts for the section. Make sure that you know that it must be 1-to-1 to have an inverse. So you want to make sure your original function is 1-to-1. Be careful when it gives you domain restrictions because you can take a quadratic and get domain restrictions, and maybe you're not looking at the whole quadratic, but you're only looking at one side of that parabola. So make sure you pay attention to that, okay? When you actually think about the inverses, you're going to interchange your members of your ordered pairs. So if you were to see AB in the function, then the inverse of that, when you're thinking about that, would be BA. So if this was f of x, then the inverse of that would be BA. Remember that the domain is the range of the inverse, and the range is the domain of the inverse. So those are going to be flip-flopped. The inverse reflects over the line y equals x, which is your identity. Remember that the first thing you want to do is check to see if it passes the vertical line test. If it doesn't pass the vertical line test, it's not a function. If it does pass the vertical line test, then check the horizontal line test to determine if the inverse is a function. Remember, to be 1-to-1, it must pass the vertical and horizontal. So in order to be 1-to-1, it must pass vertical and horizontal. So if it fails vertical, it's not 1-to-1. So it must pass vertical and it must pass horizontal to have an inverse. Remember that it is reflected over y equals x. So if you do the composition functions, f of x, when you do f of g of x, that should give you x, and g of f of x should give you x. So when you're doing the compositions, they both should give you x. And remember that the inverse function is denoted with that little power -1. Okay, good luck on your work.